The Bayesian theorem is a mathematical framework that can help you with decision making by updating your assumptions and beliefs every time you see a new evidence or every time a new data point comes up.
Developed in the 18th century by an English clergyman named Thomas Bayes and published after his death in 1763, this idea eventually became one of the most important tools in the domain of probability. Back then, it helped crack the Nazi Enigma code during World War II, and Bayesian reasoning remains an important part of modern artificial intelligence.
It basically goes like this.
In simple terms, start with what you believed before. Multiply it by how compatible the new evidence is with that belief. Then divide it by the overall probability of seeing that evidence anyway.
Now let's try to understand this with a proper case study.
Imagine you are an angel investor who has pledged $1 million to a startup. You have already given them half the funds and half are still pending in your bank. Then you get the quarterly report. They missed their revenue target. But during the emergency investor meeting, the founders point to a silver lining: a sudden massive spike in revenue over the last 30 days. They argue that the product is finally taking off and they desperately need you to wire that pending $500,000 right now to fuel the exponential growth.
Your gut reaction might be relief because you actually want them to succeed. But before making a decision, you actually saw this video. So instead of going with your gut, you decided to do the Bayesian analysis.
You look at the complete picture. You pull up your firm's historical database of 10,000 past startups and you run the numbers through Bayes Theorem. To do this, first you need your baseline assumption. Historically, what percentage of startups in this specific sector actually become profitable? Let's say your hypothetical database shows it is around 10%. So, the probability of success or P of S is 10% or 0.10. Next, you have to measure the true strength of your new evidence. You don't just look at the revenue spike, you look at the context. You note that the projections haven't just fallen short today, they have missed the mark by an average of 40% for an entire year. You look at their cash flow and they only have a month of runway left. If they don't get your pending check, they will effectively run out of cash. Finally, you look at their profit margins during this new revenue spike and you see that they have been entirely slashed. Now, if a startup is truly destined to succeed, what are the odds that they show this exact pattern? What are the odds that a good company misses their targets by 40% over a year, burns their cash flow to the brink of death, and then slashes prices to trigger a massive low profit revenue spike? Let's say that your hypothetical historical data shows that sometimes this does happen, usually due to a massive aggressive product pivot, but it only happens 15% of the time. So, the P of success based on this new evidence is 15% or 0.15. The top half of the Bayes equation is just 0.15 multiplied by 0.10. Now to find the bottom half of the equation, you have to look at the failures. If a startup is ultimately going to fail, what are the odds that the founders panic? What are the odds that they bleed their cash flow dry, realize they are going to miss targets by 40% for a straight year, and decide to generate a dramatic revenue spike by aggressively slashing margins right before asking you for a final check? Let's say your hypothetical database shows that this is quite common. Around 80% of startups going through this issue that fail do this out of survival instinct. Now let's plug this back into the Bayes theorem. Based on your hypothetical data, out of 10,000 historical startups, 1,000 will succeed. 15% of them show this pattern. That is 150 startups. 9,000 will fail. 80% of them show this same pattern. That is 7,200 startups. In total, 7,350 startups will walk into your boardroom pointing to this exact same beautiful soaring chart, and since only 150 of them actually go on to succeed, you divide 150 by 7,350. Now your updated probability of success is just under 2%.
So look at what just happened. The investors walked into the room with a good news, exploding revenue. But when you actually did your analysis, it turned out to be a warning sign. So maybe just hold on to that $500,000. See, the Bayesian theorem doesn't make the decision for you. It just helps you understand how much the new evidence should change your previously held beliefs. The decision is still yours, it just helps you make it in a more informed manner. Now I have created an AI prompt that can actually help you do this. So I have linked this AI prompt down in the description. You can basically copy paste it in any chatbot you want. It works with Claude, ChatGPT, anything. Now we just covered one example, one case study in this video. but Bayesian analysis can be used for a wide range of questions that you might have. So please give it a go and let me know how it went down in the comment section. If you like the video, please like, share, subscribe, and thanks for watching.